f of x equals x cubed plus 6x squared minus 4x minus 24. You need to know how to factor by grouping. And factoring a difference of squares. You can use a quadratic formula if it's a quadratic, but that won't take care of something like this. So there's not going to be a lot of problems where you actually have to factor, but there's going to be a few. So if we're going to set this equal to 0 to find the zeros, first of all, we know the leading term here because this one's multiplied out. Leading term is x cubed. We know it's positive and odd. So we know the graph is going to look something like this. The y-intercept is a freebie on this one. It's 0, negative 24. Because if I plug 0 in for x, it's going to wipe all these out and leave me the negative 24. But to get the zeros, I've got to factor this. So I take my x squared, x cubed plus 6x squared minus 4x minus 24 equals 0. I can factor an x squared out of this, which will leave x plus 6. Bring down the negative. Carry this over. Well, that's sloppy. That's 6. These are parentheses. I'm going to need a 4 here so that this times this will give me the negative 4x. So I need to double check. Negative 4 times a positive 6 is negative 24. Okay, we're good. So this factors as x squared minus 4 times x plus 6. Still trying to solve where it's equal to 0. This is a difference of squares, and we'll factor again. So this is x plus 2, x minus 2, factors into the conjugates, times x plus 6 equals 0. So my zeros are going to be negative 2 from this one, positive 2 from this one, and a negative 6 from this one. So my x-intercepts are negative 2, 0, 2, 0, and negative 6, 0. So I've got negative 2, 0, positive 2, 0, 2, 3, 4, 5, 6. Very good. Over here. Okay. These are all multiplicity 1. So the graph's going to go through at all of these. I know it goes up forever over at this end, down forever over at this end. To get this, it goes through. So it's going to be up here. It's going to hit this one again, come back through, come down here somewhere, come back up here, and it's going to go through. So check, check, check. What if we had x to the 4th minus 9x squared plus 18. Now this is not a quadratic because it's an x to the fourth, although it's going to have the same shape as an x to the fourth, or the same shape as a quadratic. This can have up to 3 turnaround points. Whoop, I accidentally pushing a button. The turnaround points are where you have maximum and minimum values. So they may be calling them extrema or something like that. That's your max and min points. A graph cannot change direction going down to up or going up to down. It cannot change more than one less time than what the biggest exponent is. So an x to the fourth might just go like that. It could go like this, where this one has 1, 2, 3 turnaround points. This one only has 1. Both of these would be positive and even. This one cannot be an x squared. So this one could look like this, but it could actually look like this. It cannot have, let me say, no more than 3 turnaround points. When you factor this, when you factor something like this, where it looks a whole lot like a quadratic, it's not a cube. It doesn't have 3 factors. It's going to have 4 factors. But because it does not have any of the odd exponents, it'll graph as though it were a quadratic. You've got your constant term, your middle term, and then your first term where the exponent is double the one from the middle term. So if I put an x squared here and here, this times this is going to give me x to the fourth. My outer terms and my inner terms are both going to be x squareds, and that has to total up to a negative 9 x squareds. And then this times this still has to give me 18. Well, the factors of 18 that would add up to 9 would be 6 and 3. And to get a negative 9 out of that, it'd need to be a negative 6 and a negative 3. If I set this equal to 0, x squared minus 6 equals 0 is going to give me x squared equals 6, or x equals plus or minus the square root of 6. X squared minus 3 equals 0 is going to give me x squared equals 3, or x equals plus or minus the square root of 3. So this is going to have x-intercepts at the square root of 6, 0, the negative square root of 6, 0, square root of 3, 0, and negative square root of 3, 0. Now I know that the square root of 3 is approximately 1.73. So I know that it's going to be between 1 and 2. And the square root of 6, 2 squared is 4, 3 squared is 9. So this is going to be somewhere between 2 and 3. If I run it out to a decimal place, let's see, 6 square root is about 2.4. So this is about 2.40 and negative 2.40, since I don't know exactly where these numbers are on the number line. So I know the square root of 3 is going to be on the in between 0 and the square root of 6, and the negative square root of 3, And the negative square root of 6 would be in this order. The square root of 6 is farther from 0 than the square root of 3. Oh, my y-intercept here is going to be at 0, 18. I'm going to call this 0, 18. Okay, so to get this shape, I know it has to come up. These are all multiplicity 1. So it's going to go through. So I know this will go through here, comes back up here, up to there, back down here, something like that. So it's going to be more like this shape than this one.